Okay, good morning. Welcome to
SuperMath number 35.
SuperMath35. But today we talked about side angle side similarity. So not side angle side congruence, but side angle side similarity. And we're just going to do a very straightforward example for the movie today. So I have these two triangles. One lives inside the other one. A, B, C, and A, D, E. And I know that A, D is 3, D, E is 5, and AE is 6, and then I know these other sides here.
But AE is 4.
AE is 4, sorry. Ugh. Gonna be a long day. AE is 4. And I know these other other sides are 6 and 8. And what we're trying to figure out is how long is that? And we're going to use our side angle side similarity to do it. So, but before we start in on that, can you explain sort of right here what the rule for side angle side similarity is?
Well, you need two sides of a triangle and the angle between them. So I'll call this one X and this one Y.
Alright.
Then on the triangle that you want to be similar, if we have this, like, let's say there's a coefficient K times X and K times Y, these triangles would be similar.
Okay, that's exactly right. So they've been multiplied by the same amount. And how do we test whether we have this situation? What do we use to find that out?
Well, we need these lengths and the measure of this angle.
Okay. And what else?
And these lengths and the measure of this angle.
Alright. And once we have those, what do we do to test that this is multiplied by some number K?
We want X over Kx to equal Y over Ky.
Alright, very good. Very good. Or in the triangles itself, we could have X over Y equals Kx over Ky. Okay, this is what we would want. So either you can do it by the corresponding sides like you did, X to Kx, Y to Ky, or you can do it in the triangle itself, X to Y, Kx to Ky. Alright? And if that ratio is the same, either the ratio of the corresponding sides or the ratio of the sides in the triangles themselves, if that ratio is the same and the angle in the middle is the same, then the triangles are similar. Okay? So what are we going to say here for these two triangles that we have on the board?
Well, we already have a nice angle that we can use since they share this angle.
Alright, so we're good on the angle.
And then we have to use this side and the whole side and this side and the whole side.
Okay.
So I'll do it in the triangle itself.
Alright.
So we have 3 to 4. Does this equal? So 9 to 12.
Alright.
So we can cancel 3. So this does work.
Does work, okay. So what two triangles do we know are similar? Can you write them down?
Triangle ADE and triangle ABC.
Alright, those two triangles are similar by side angle side similarity. So now if we want to find BC, what do we do?
Well, we need to have this 5 and multiply it by 3/4. Wait, no. We have to multiply it by 3.
Why 3?
Because this side's 3, this whole side's 9.
Okay.
This side's 4, that whole side's 12.
Alright. Good. So this side is going to be what?
So it's going to be 15.
Okay. Now, initially you said let's multiply by 3/4. Okay, how can we tell very quickly that multiplying this side by 3/4 is not going to be right?
Well, it's not going to be an integer for one.
Well, that's okay though, because not all triangle side lengths are integers.
But it's going to be less than 5.
Ah, multiplying 5 by 3/4 gives you a number that's less than 5. How did we know, without knowing what this was, that it was going to be bigger than 5?
Well,
This
because because this triangle is smaller. Or from these two side lengths.
Okay. This triangle, this 3, 4, 5 triangle lives inside of whatever this is, this 9, 12, and whatever this is. So we know this side here is bigger than that side just by looking at the picture. Right? Because this triangle is inside of that one. So it has to be bigger than 5. So we're not multiplying by 3/4. In fact, we're multiplying by
3.
3, because 3 went to 9, 3 went to 9, 4 went to 12. That was the ratio.
And 3/4 is just the ratio.
3/4 is just the ratio of these
Yeah.
two sides to each other. It doesn't relate the two triangles to each other. Okay, good. Good job, sweetie. Good job, Smart.